So continuing on, this is really like a part 2 of our last class. Last class we talked about what is inheritance. Now we're going to talk about, from the point of view of we know what inheritance is. So suppose we had a situation where we had a class called, let's say we were a company and we were making a lot of electronic products. And for example, we make clocks, and we make radios, and we can make many other products too, smartphones, dumb phones. And, we can make products that plug into an outlet in a house, products that plug into a car radio, a car charger. But maybe all of our products have some things in common which we might capture in what we talked about last class was an abstract class. So maybe an abstract class like electronics. That's not an actual product. You would never walk into a store and say, I'd like to buy 2 electronics. It would say, which kind, right? It's a clock, a radio, or something like that. But there might be things that that all our products that we're going to make will have in common. Like, for example, they may all have a field in it called a serial number. Or they may have a method, or when you power one of these objects up, maybe we want our company logo to appear as the first thing that powers up. And then it could do other things like powering up a clock and a radio. So we may have a method called power up, which does things that should happen for all our products. Okay, and then since we don't want anybody to ever instantiate an electronics, in Java we actually spell out, there's a keyword in Java called abstract. So we'd say the class it's an abstract class called electronics, and we define stuff that's in the class. And then we can now make a new class called clock, which extends electronics. So that means we inherit from electronics. We get all the storage fields and the methods from electronics, gets added to clock, and then we can add more stuff that is specific to a clock, like methods like set the time and set the alarm and run the clock and that kind of stuff. Then we can make a different class called radios, which also extends electronics. So we inherit everything from electronics, and then we add more stuff that is just for radios. So what if we found ourselves in a situation where, now remember, when you're doing inheritance, a clock is a specific type of electronics. We're taking the class electronics, which is somewhat vague, and we're making it more specific. We're taking everything from electronics and then adding stuff that's only special to a clock. So you might think it would be strange to multiply inherit because we have 2 different objects, and to say one is a specific version of the others, that might seem a little odd, but sometimes it happens. Like, for example, maybe some of you have a clock radio. So a clock radio is a special type of a clock. It's a clock with a radio in it. Or you can think of it as a special type of radio. It's a radio with a clock in it. So there might be a situation where you want to multiply inherit to make something called a clock radio. And it would be great if we could do this because we get all the functions and the data storage, for AM, PM, and hours, minutes, and seconds, and all the software that runs the clock. And then all the storage for like what volume is the radio and what's the radio station currently set to and how to change the station. So we get all that functionality. If later on down the road we added a new feature to the radio, maybe we added satellite radio, we add it here and it gets inherited into here and we pick it up right away. So you might think it would be a good idea to allow multiple inheritance in a programming language. And actually C++ does allow this. C++ was probably the most famous original, it wasn't the original object-oriented language, but it's the most famous of the original ones. And it came out around 1985. And some of the issues that come up in multiple inheritance, let me just go back to this picture. And really what I'm doing is, what we're talking about today is a new topic in Java called interfaces. So I'm kind of giving the motivation for why it came about that we have this. But if we had, for example, if you multiply inherited from electronics to make a clock radio, and inside the class electronics there was a field called the serial number, we would now have two serial numbers, right? Because we'd inherit two of them. We'd inherit the one that came from clock, and we'd inherit another one from radio. But electronic devices should only have one serial number. And let's say, for example, there was a method in here called power up, which every time you plug an electronic device in, we want the first thing to happen to be our company logo to come up. We would put our company logo up, then the clock would initialize to whatever clock initializes to 12 a.m. or whatever we would set in this initialization when it's powering up. Then the radio component would power up, which would cause our logo to appear again. Or if there's some bell or sound we make, it would make it twice. So you're inheriting two copies of everything. So in a language like C++, you have to start peppering words in that say, you know, to throw the word virtual around to make sure you say, I only want one copy of the serial number, not two. But maybe sometimes you want two, and sometimes you want one. So the idea was that this allowing multiple inheritance, and I guess it existed for about 10 years before the designers of Java said it's more dangerous than it is beneficial to have. So they decided to get rid of allowing multiple inheritance. And some of the issues are data in common in the base class gets duplicated, for an example, like a field like a serial number. Methods in a base class can be overloaded. For example, you could have a power-up method in your base class, and then clock rewrites it, and maybe radio doesn't rewrite it. Now you don't know which one you want to call, the clock version or for the radio should you call it the one that came from its base class. And then you could also have features in the two classes you're inheriting from, like clock and radio. Maybe they both have a method called make louder. So so for the clock it might make the alarm louder, and for the radio it might make the radio louder, and if you want to call make louder, which one do you call? And you, who's inheriting from both, would have to then write code that distinguishes between the two, which starts to take away the advantage of multiple inheritance. So then you might say, well, maybe the designers of Java did me a favor by taking this away, so I don't hurt myself. But now I'm somewhat limited. If I wanted to do, if I wanted to create a class called clock radio, and I can't multiply inherit, then all I could really do is, and obviously the electronics class, everything has to inherit from. I really have to inherit from electronics directly, and then I can have all the features of a clock and a radio by, instead of inheriting from them, create an object of that type and put that in my class. So really what I'm doing here is I'm inheriting directly from electronics, and then I'm creating one object called the clock. I give it a name C, and I create one radio, and I call it R. So if I was allowed to multiply inherit every feature of a clock, I could just refer to by the object dot the method name. Now I would have to say the object dot the C part dot the clock method name, or the object's reference dot R dot the clock's name. So just, you know, one layer of abstraction from it. So for example, if my clock class, which extends electronics, had a method in it called set alarm, let's say it had like a set time and a set alarm. Well, let's say for example, the set time method. I give it an hour and a minute, and I set the actual field in my object. So if I was able to inherit it, I would just get a method called set time. I could take the object dot set time and set the time. But now, since I can't multiply inherit, I make clock radio extend directly from electronics. Then I add a piece of storage called a clock, give it a name C, and a radio and R. Now I have to add a new method called set time. Someone gives me an hour and a minute, and then I set the C part of my object, call its set time method, and then it'll call this method. So this function is just sometimes called a wrapper function. I'm just putting a wrapper around this function, so it could be called, because I can't call it directly. And I would like all the code that says, for clock, set the time, I'd like that to go untouched. So now I have a method called set time. So I can make a clock radio and just directly call set time, which then implicitly calls this function. So the annoying part is, if you want to multiply inherit, you can't. So you create an object of each type of the thing you would like to inherit from. And then, unfortunately, every method that these classes have, you would have to write a wrapper method that calls the method on either the clock part or the radio part. So if they came along a year or two later and decided to add something new, like satellite radio, and they added 10 more functions for satellite radio, you have to come into your clock radio class and add 10 more wrapper functions that call those functions. So it's not as simple as just inherit and you're done. Now you have to get all the functions and write the wrapper function for it.
Can we use like just the one set time or set alarm? Why are we using like the same parameter, right? The hour and minute.
So wait, you're saying can we use this one or this one?
Can we just use the set time for both? Like for C dot set time and R dot set time, like that?
Oh, no, in this example, no, so in this example, a radio doesn't have a set time function. So I'm just saying, if you wanted to, suppose you had some code that creates a clock and then calls its set time function. Now you'd like to go and do the same thing. You'd like to make a clock radio and call its set time function. Since we're not inheriting, we're creating an object, we don't have a set time function here. Our clock radio class doesn't have a set time function. The clock does, but the only way you can call it, like if we made an object clock radio CR equals new clock radio. We had an object called CR. We can't call set time on CR. We'd have to say CR.C dot set time, because only the .c part has that method. But if all our code would like our clock radio class to also have a set time, and we're not inheriting now because we did it by composition, we don't have a set time method. So what we can do is we can add one which just calls the c.setTime method. So all it's really doing is we're just having this name match this name, but putting the object in front of it to know which one to call. So if our radio class had a method called like set station, the radio station, we could then add void set station and then put in whatever number you're setting the station to, and then call r.setStation. So it's just basically, yeah, the annoying part about not being allowed to multiply inherit and instead using composition to actually create an object of each type within our class, which is effectively like inheriting, because we need the storage anyway. When we inherit, we get the storage for free. Here we have to actually go and say, I would like this piece of storage and this piece of storage. But now all the methods don't get inherited. You have to actually call that, create a class just, method just like it that calls the method you're trying to create. So yeah, so the annoying part is, one of the big benefits of multiple inheritance is if someone later on adds to the functionality of a radio, we don't have to change anything. We just recompile and we pick up all the new functions. Now you have to actually add more of these headings. That's the only drawback. But it saves us from all the things that could go wrong with multiple inheritance. Supposedly, that's what the designers of Java thought. It would be better to take it out and let you deal with composing an object of multiple parts rather than multiply inherited. Okay, so in C++ or in a language where you can multiply inherit, suppose somebody wanted to create a class, and this might sound strange, but suppose somebody wanted to create a class that has no storage, no data, no primitive types, nothing that takes up space, just maybe a couple of methods. And like I said, there would be pure virtual functions, meaning the methods have no body. So this would be a strange class. It's just a class with a couple of methods, and the methods have no body. And in C++, you can inherit them. well, that would then force you to have to provide a body for those. Well, those are called interfaces, interface classes in C++. And Java actually created another keyword called interface. So you can actually create what somewhat seems like a class. You can create what's called an interface. So an interface is a description of a capability. It lists methods that the class must implement to carry out that capability. So a class may implement multiple interfaces. So you can't multiply inherit, but you can implement multiple interfaces. And an interface may be implemented by many classes. So I think an example might be a little bit better. So suppose, for example, we're making electronic products, and we decided that some of our electronic products need to have a feature in it that if the product gets too hot, it should automatically shut off. So do your cell phones do that?
Yes.
Yeah.
You've had it shut off if it's too
Yeah.
hot? Okay. But then maybe some products don't have, now if we decided every product we ever make should have an emergency shut off, and you're designing our classes, then where would you put the function called emergency shut off? If every product has one.
In the electronics.
In the electronics, because everything's gonna inherit from there. But what if only some of our products should have a method called, like a Boolean method that says the device is too hot, and if it's too hot, then do a auto shut off. If only some of them should have that, then what should we do? So this is it's kind of a design question. If we put it in electronics, if we put a method in electronics called auto shut off and a Boolean function that checks if the device is too hot, then we're going to have every product we ever make that inherits from electronics, the designer of that class is forced to write code for when the thing should shut off. And maybe it's like a clock inside your house that doesn't have to shut off. So if we were going to put this feature in some of our objects, not all, where would you put it?
In the class that would want to be in, whether it be like a clock or radio.
Right, yeah, I guess just, put the methods where they belong.
Mm-hmm.
But what if, that's a good point, and that's where we want to put them. But what if we wanted the design of that code to follow a similar pattern? So really, like, the people who make the class can do it their way, and the people who make the radio class could do it another way. But suppose you decided, I want to have, for every product that has an emergency shut-off, I want there to be a Boolean method called device too hot, and I would like there to be a method that shuts everything down if the device is too hot. And I want every class to have that function, so they don't just can go, willy-nilly make their own functions. So, if we wanted something like that, if we wanted every piece of electronics that we make to have a Boolean method, if we decide this is the type of electronics that should have an emergency shut-off, it should have a Boolean method called device too hot, which is either true or false. And if it's too hot, then an auto shut-off should be called. So for example, their code would say something like, so now what we could do is, for every object that should be an emergency shut-off, we should be able to check, if too hot, shut it off, if too hot, shut it off. We'd be able to do this for every method. So we'd like every method, we'd like every class that we consider needing this feature to be required to have it. So I'd like to, now you might think, why don't we make another abstract class called, auto shutoff, and then make everyone inherit from electronics and from auto shutoff. Well, Java doesn't allow multiple inheritance, so we couldn't do that. The main reason they don't allow multiple inheritance is they don't want two sets of data getting inherited multiple times, and they don't want methods with different bodies getting inherited and you don't know which method to call. But if you have an interface which just has names of methods and then tells the inheriting class or the implementing class to provide the bodies for it, then you don't get multiple data because there is no data to get. You don't get multiple copies of data, and you don't get the body of the method being overwritten by one class you're inheriting from and not from the other, and you don't know which one to use. So for example, we could say class radio, like we had before, it extends, meaning inherits from, electronics. You can only inherit from one class. And then we can say in addition to that, it doesn't inherit, or it doesn't extend, but it implements the auto shutoff feature. So, so then we describe, then we put in features about a radio, but because we implemented auto shutoff, we are required, or we'd have a compiler error, we are required to implement the bodies for the Boolean function device2hot, which takes in an integer t. We check if the temperature is greater than 98, return true, otherwise return false. So it's basically just going to answer, is the device too hot, yes or no? And then we have to have another method called auto shutoff. Because we implemented this interface, and like I say, an interface is like a very limited version of a class. It has no data, and the methods have no body. Right? A class can have data plus methods, and inside the methods you describe what to do. An interface has no data, and it just has method signatures with no body. If you implement it, you are required to supply the body. So here we would say auto shut off, and then we'd say if the device is too hot, so it calls this method, and if it's too hot, then whatever it takes to shut off a radio. Radio when it's too hot. Whatever data needs to be saved, or whatever's involved, we would then describe that. So now, we have a way, since we have an interface called auto shutoff, any one of our electronic products that we decide needs to have an auto shutoff feature, we would, of course, everything has to extend from electronics, and then we would say implements the auto shutoff feature. Any products that don't have to do it, we just won't implement it, just leave that part out. So this is a way we can, we're not really multiply inheriting, but we're taking a capability, the ability to check if the thing's overheating, and if so, shut it off, and implement that for each of the objects.
So you could think of interfaces like placeholders?
Yeah, it's to say, I mean, you could kind of think of it like we're trying to multiply inherit. We're taking things that are electronics, and then some of them are also have a feature where they could auto shut off. But as soon as you inherit, as soon as we allow multiple inheritance, we're opening our door to the two things we inheriting from something in common, and now getting common data and common methods. So as long as the interface, I kind of think of it as a class that has no data and the methods have no bodies, we can inherit multiply from them, and we're not going to get all this confusing overlap of data because there is no data. And we're not going to get confusion about should I use this method or the one I inherited from someone else, because the method has no body. I'm required to supply the body. Therefore, there's no confusion about which body I'm using. It's the one I wrote. So it's a very limited class, and because it's so limited, we can inherit or actually implement multiple times. So it's not so much a placeholder, but a set of functions. They just call it a capability. Your object now is capable of doing this task, but you're required to supply how to do it. So it has the ability to shut off automatically. But how it does it is you, the creator of the clock class or the radio class, is required to describe how to do it. It's just that now your object is one that can do this. It can shut off automatically. Okay, so interfaces are like classes. It's compiled into bytecode and makes its own .class file when you compile with it. The public, private, public, protected, private, and package modifiers exist for all of them. It can't be public unless it's the same name as the file, and serves as a type in declaring variables or references. I should have said references there. Okay. Interfaces are not like classes in that declares only method headers, no method bodies allowed. Cannot declare data storage, only public constants. So yeah, I was kind of taking a shortcut when I was saying there's no storage with it, but we can make static variables, which are just constants that never change values, so they don't take up space. So that you're allowed to add to an interface if it made sense to them. They don't have constructors because we don't, constructors set initial values to storage, and there is no storage. So therefore there's no constructors in an interface. We can't instantiate an object of an interface, so we can't just say there's a auto shutoff object X equals new auto shutoff, because there's no storage and there's no methods to do anything with the storage, so that wouldn't make sense. They can be implemented by a class, so we can create a class that implements it. Cannot implement an interface, but can extend an interface. So, an interface cannot implement another interface, but we can extend it. I kind of go over a little example later on. We can extend it to say an interface has a capability and then it can extend to another capability, have more capability. Okay. Cannot extend the class and can extend several other interfaces.
Can we use private or public with the interface?
Yeah, so all the same keywords. We'll talk more in detail about, so really the four types are public, protected, private, and then a thing called package or what's default. So if you don't say one of these, public, private, or protected, it's actually package, which means anything within the same package of it can see it, but outside of the package can't. But all of these are the same for interfaces and classes. Okay, so then these could be, valid data types in Java, interface, class, arrays, or primitives. So we can make objects, we can refer to objects by those. Okay, so for example, we can have an interface, ABC, and we put some methods, method signatures really, shouldn't put bodies in. And now we can say, I have a new interface, XYZ, which extends the interface ABC. So really all you're doing is adding more methods. So you have, let's say this had 3 method signatures and now you have 2 more. So now XYZ has 5 method signatures. These 3 plus these 2. You're just adding to them. So we can extend an interface like we extend classes. And you could do this multiple times. This is allowed multiple times. And then we can say a class implements X, Y, and Z. So if this class C was to implement the interface X, Y, and Z, it would have to actually write the bodies for everything from A, B, and C, and everything from X, Y, and Z, which was added. It has to do them all. Okay. Multiple interface example. We could say if we had an interface A, B, and C and a totally separate interface X, Y, and Z, maybe like for our electronics class we have it has to have an automatic shutoff interface, and maybe an interface where it can operate underwater. Well, now we can make a class that has auto shutoff and can operate underwater. So you'd have to again supply all the bodies for A, B, and C and X, Y, and Z. So the previous slide, basically X, Y, and Z extended A, B, and C. So all we had to do is implement X, Y, and Z. Now we're going to say we implement both interfaces. So you can only inherit once, but you can have multiple interfaces that you implement. The reason we can do the multiple ones is they have no storage, and the bodies of the methods have no bodies, so there's no conflicts. That's why they let you do this multiple times. So this is really kind of, they took away multiple inheritance and added interfaces. So it's somewhat like multiple inheritance, but you can't hurt yourself with the issues that come up in multiple inheritance. Okay. So here's an example, one that Java supplies you, an interface that Java supplies you. Have you ever used this one in Java 1 where you have an object and you call compare to another object? Is A greater than B? So you've used compare to.
Yes.
Yes.
Oh, good. So you created an object and then you said, if A compared to B, and if it came back in 0, would they were equal, a negative number, the first one was less than, and a positive, right? So you could check the result if greater than 0, if 0. But you didn't write this method, right, compared to, right? Someone else did. So what happened in that case was, well, do you know where it came from? Compared to it came from?
Assuming
Library.
library.
The object.
The object class, right. So every class you create that does not extend anything, by definition extends a class called object,
Yes.
which Java supplies to you. If you extend something, then that thing had to derive from object. So everything really comes from object. And the method compared to, so the class object implements the class object implements comparable. Comparable is an interface, and comparable has one method, header in it, called compare to. And then object gave the body to it and just says if A is greater than B, you know, and return -1 or 0 or +1. And the idea is if A is less than, if the left side is less than the right side, return a negative number. If they're equal, return 0 and positive number otherwise. So, in your Java 1 class, did you use it or did you have to write the method? You just compared two objects using compare to?
Yes.
Like a 2 integers or something?
Either 2 integers or 2 strings.
Okay, so the primitive types are all defined, what it means to be less than, greater than, or equal to. But suppose we had, for example, student extends a person and implements comparable, right? Now it would already implement comparable because person inherited from object and student inherited from person. So every student would have a comparable function. But I'm saying it implements comparable. That allows me to write a new body for compare to. Now, if you were to define, how can you say one student is greater than the other? What would the definition of being greater than or less than the other? So in this case, I actually made it based on age. But we could have done it many ways, right? We could say grade point average or years at school or something like that. So I decided to define compare to be less than or greater than. For one student to be less than or greater than another, it's based on your age. So I basically took I passed in an object and I casted it to a student, and I said I have that student, and I say I'm going to compare this student's age to that student's age. This is the one, this is the reference to the internal object, and that is the one I just created for the student being compared to. And then I just return a number based on their age. So this is my way of saying if I create a class, and it's my own thing, a student, which is an abstract concept, if I want to define what it means to be greater, one student to be greater than, less than, or equal to another, I could define it any way I want. So I decided to use age to define that function. So again, could have made it anything I wanted. GPA, or who's been at the university longer is greater than the other. But it allows you, because everything in object implements comparable, it allows you to define what it is to be greater than, less than, or equal to. Okay, and then, the last topic is polymorphism. So here's the idea where, so the word polymorphism, poly means many, right? And morph means, different shapes. So you could take on different shapes and different objects, and an object may be referred to by a reference that is either of its type. So for example, we could create a reference for a clock radio, or we would create a reference for a clock and refer to a clock with it. We could also create a reference to an electronics and refer to a clock with it. So we can refer to it by something of its own type, or any type it inherited from, or of an interface of any class, of anything its class implements, or of an interface implemented by the class it inherited from. So, for example, suppose we had a class, again, we have our abstract class electronics, and electronics implements a power-on interface, and then clock extends electronics, and then we fill in stuff about clocks. Radio extends electronics, clock radio extends electronics, and we write our wrapper classes in there. What we could do is, even though electronics is an abstract class, we could never make an object of type electronics. We could say I have an electronic reference, EC, which is going to be like an electronic version of a clock. And I could say equals new clock, and this would compile. So do you have any comment on, like, if you were designing the programming language, would you allow this or not allow this? So for example, in your electronics class, maybe we have a field called a serial number. And in our clock class, we have fields like hours, minutes, and seconds. So if I was to create an object of type electronics, and then say new clock, I've created a clock object. The clock object is going to have a serial number field, and let's say a hours and minutes field. But I can refer to it from an electronics. So do you see an issue, or would you allow this or not allow it, or if you allowed it, there's an issue to it?
Is that an issue with memory or something?
Right. So the question is, if an electronic device doesn't have hours and minutes, that's only specific to a clock. And here I could say an electronic radio is a new radio. And this might have fields in it like what radio station you're set to and what's the volume, but clocks don't have that. So if I started referring to ER dot volume, what am I referring to? Because electronics don't have a volume, and should I be able to?
I think you should.
If that was allowed, it's kind of interesting. It is kind of debatable. So, well, let me just go through this slide, and then we'll get to that point. So I can make an electronic EC, which is a clock, an electronic ER, that's my reference, a radio, and then an ECR for a clock radio. Now what I could do is I can create a power-on, which is just a power-on object. This is now, in this case, I'm saying I have an interface called a power-on. So this is an object that has the ability to turn on. I don't know what it is. I don't know if it's a clock, a radio, whatever. It's just something that has the ability to turn on. And I set it equal to my electronic clock. And now I can call power on on this object. Now, should I be able to start calling like set time and functions that are very specific to a clock using this reference? So, like for example, I could say EC power up. I could say ER print the serial number, because I inherited serial number from electronics, or print serial number. But what I can't do is I can't say take the clock radio and call the set time method, because the clock radio, well, here's where it kind of gets debatable. An electronics doesn't have a method called set time. Only clocks and clock radios have those. So if I was to take an electronic object and call set time and try to change the time of day, what if this happened to be referring to a radio at the moment and can't set its time? So the compiler may not know that this is an object that can or cannot set time. It knows what electronics can and cannot do, but doesn't know at the time this line ran, what is this thing pointing to? Is it pointing to something that could have its time set or not? So that what we could do, what they could have decided to do is, and did typecasting come up in Java 1? Where you have an object of one type and you put in parentheses what you'd like to convert it to?
Yeah.
Briefly, Yeah.
Okay.
Yeah.
So, like maybe if you had an integer and you wanted to convert it into a float, you'd write, open paren, float, close paren, and then it converts it.
Mhm.
So what we could have done, what Java could have been designed to do, was to say, okay, it looks like I'm calling a method that doesn't exist in here. Let me think of all the classes that inherit from electronics and see if that has a set time function, and then dynamically cast type it to that type so it could then run. But is any argument that that could be dangerous? You know what I'm saying? So at this point, the reference ECR happens to be pointing at a clock radio. It's of type electronics. It happens to be pointing at a piece of electronics that has other features to it, clock and radio stuff. I go to set the time. So should Java implicitly cast it to a clock radio and then set its time, or not? Or should it cause a compiler error? And yeah, the reason is, I try to put as much into a small slide, is there are two things that can set a time, a clock or a radio. And this thing doesn't know if it's a clock or a clock radio. But if it implicitly casted it for you so you could run this function, it may cast it to the wrong object. But you could cast it. You could take ECR and cast it to a clock radio and then call this method. And then it would run. So they leave it up to you to do. Okay, and then just to kind of have an example, other than talking about clock radios all the time. Suppose we had an abstract class. Suppose we had an abstract class called shapes, which implements an interface called drawable. So that would be anything that could be drawn. You would think anything that's a shape could be drawn, but suppose, so anything that's a shape has the ability to be drawn. So in the drawables interface is a bunch of methods on how to draw stuff. So now we can have a class called circle, which extends shapes. And we could have a class square, which extends shapes. Now, are circles and squares required to implement all the functions in drawable, the way this is written? So what we're doing is, circle is inheriting from shapes, and shapes implements drawables. So now anything that inherits from shapes is required to implement every function in the drawable interface. So now if they have a method called draw, let's say there's only one method in it called draw, you have to implement it. So I can create a drawable object. Its reference is DC, it's a name I make up, and it's a new circle, a drawable circle, and a drawable square. I create a new square. I can now call the method draw, assuming in this ... the draw method was added to describe how to draw a circle and how to draw a square. Okay, so the DC draw calls the drawable method in circle.
I'm sorry, just as a refresh, where would you write the code for drawables? You'd have to write it within square and circle?
Right, so the idea is in the drawable interface, and like we said earlier, an interface is kind of like a very limited class. A class can have storage and methods that operate on the storage. A interface cannot have storage except for constants, cannot have storage, and all the methods do not have any bodies. They just have names and signatures. So if you implement it, you are required to give the body for it. If you don't give the body, it won't compile. So the draw function would have to be within the class that is implementing. So the square and the circle, because how you draw a square and how you draw a circle are different, but we want all of these shapes to be able to draw them. Maybe we're building an application where every shape we create has to be something you could draw. Right, and then if you had an area function for a square, you couldn't call it directly, in this case. Actually, this should be a method in the square. Okay. Sorry about that. Okay. All right, so that's the end of the slides anyway. So I'll change this. This should say method in square. Okay. So, yeah, so then in this case, suppose there was a function called area. What is the area of something? But it's not in the drawable interface. It just happens to be, let's say each one of these shapes has a method called area in it, but has nothing to do with the drawable interface. If you then take ds, which is a reference to a drawable object, even though ds is referring to a square at the moment, it only knows about the drawable methods, not whatever methods happen to also be in the square at the moment. Again, so this is back to that issue. We could typecast it back to a square, and then you could call area. But right now, the compiler doesn't know, does ds point to something that has an area function or not? And since it doesn't know, it's not going to go looking through a list of all the things it could be pointing at and see if that has a drawable one, and the first one it finds, call that, because it won't know if it found the right one.
So the area should be in the drawables?
Well, okay, so if the area function was listed up here, then these two would be required to implement it, and then it could call it, because it knows it's calling the one that was implemented for this. So right now, I guess what I'm saying is, the variable ds, which happens to be pointing to a square, the compiler would not know if this object, which happens to be pointing to a square, is pointing to something that has a function called area. Because it would know it if it was listed up here, then it would be forced to be here, and then you could call it. But yeah, I guess I should have said in this slide, area is a function within a square class, within here, but not in drawable. So the compiler won't know if the area function applies to that object or not. So it won't compile.
So when you make an object using the drawables interface, it really can, the only actions you can do on DC or DS would have to be in drawables.
Right,
Okay.
exactly, that's important. So because these things refer, these are references to, well, one is a reference to a circle, one is a reference to a square. The only thing you know for sure is every method in drawable must appear here. That you know. So when you use these references, you could call any method that appears up here, because these would be required to have them. But since area, and maybe I should have spelled this out, area is not in drawable. It just happens to be something that's part of square. But when we go to call it, the compiler wouldn't know. It doesn't know what it's going to be pointing at the moment. It could figure out dynamically, based on what it's pointing at, it could then figure out, does this thing have that function? But it ends up throwing a compiler error because it says, I don't know if the area function is something that this thing is pointing to.
So to get around that, would you just add the area function to drawables?
If you do that, if let's say, that's not a great example, but suppose squares have an area function and circles don't, even though we could figure out the area of a circle. If you put it up here, you're requiring everything that implements it to.
So you'd have to make circle have it too then.
Right. If anything you put in drawable, you're forcing everything that implements it to supply it.
Okay.
And if you, now what you could do is you could make another interface called area, area shapes, and put it in there, and then have circle not implement area shapes, but square does, and then you'd be able to call it. So yeah, that might be an example where you start having multiple interfaces.
So then you could say square implements area, and then DS would then work with area, even though it's not in drawables.
Right. If we had another class called, let's say, area.
Okay.
Area shapes with areas. And in there, we had a function called area.
Mm-hmm.
And square extends shapes, comma, area shapes. Then we know for sure it's gotta be there. It would have never compiled if it's not there, and then you could call it, because you know for sure it's there. So you just can't call the stuff on, can't call functions if the compiler is not sure this thing is referring to an object that has one. Yeah, so that's a good point.